Hi everybody, welcome to the Unit 1 Part 2 test review. We're going to start off with some absolute value equations. So for an absolute value equation, when we plug our answer back in and simplify, whatever is inside of these straight up and down lines, the absolute value symbol, we are going to make it positive because absolute value means the distance away from zero. So we have to consider two cases, when this is a positive inside of here and when this is a negative inside of here. Because this could be equal to -1, then we will take the absolute value and it makes it a positive one. So my two cases are p divided by 4 equals 1 and p divided by 4 equals -1. To get p by itself, I will multiply both sides of my equation by 4, giving me an answer of p equals 4, and also multiplying both sides here by 4, giving me a solution of p equals -4. So when I plug these back in, 4 divided by 4 is 1, the absolute value of 1 is 1, and 1 equals 1. -4 divided by +4 is -1. But the absolute value of -1 is +1, so 1 equals 1. I'm going to use the same technique over here and set 3k minus 1 equal to 7 and 3k minus 1 equal to -7. Adding 1 to both sides gives me 3k is equal to 8, and dividing both sides by 3 gives me k is equal to 8 divided by 3. Over here, I'm also going to add 1 to both sides on case 2, but -7 plus 1 gives me -6. So when I divide both sides by 3, I get a solution of -2. Number 3 is a little more tricky because we have all kinds of stuff going on outside of the absolute value, and we have to isolate this absolute value first before we can set up our two cases. So first I will subtract the 7, leaving me with -5 times -5x minus 8 is equal to -90. Divide both sides by -5. So my absolute value of -5x minus 8 is going to be equal to, those are both negative, +18. So case 1 is -5x minus 8 is equal to 18, while case 2 is -5x minus 8 is equal to -18. Just like before, I'm going to add 8 to both sides. This gives me -5x is equal to 26, and divide both sides by -5. So one of my solutions is -26/5. I'm also going to add 8 on both sides here, but this is going to leave me with -5x is equal to -10. So when I divide both sides by -5, this solution gives me a 2. Number 4 works similarly to number 3. I have to isolate this absolute value first. So I will subtract 8 on both sides. I will divide both sides by -5, leaving me with the absolute value of -8x minus 3 is equal to 3. Now I'm going to set up my two cases. -8x minus 3 equals 3, and -8x minus 3 equals -3. I am, of course, going to add 3 to both sides, giving me -8x equals 6. When I divide both sides by -8, that's -3/4 after I reduce. Adding 3 here actually gives me 0. That is okay. 0 can be a solution. Divide both sides by -8, I still am getting 0. Let's check out this 0 just to make sure. -8 times 0 is 0. 0 minus 3 is -3. the absolute value of negative 3 is positive 3. Now I have negative 5 times positive 3, that's negative 15, plus 8 does give me my negative 7. So it's always good to check if you're not sure. Plugging it back in and making sure the left side of the equation is equal to negative 7 once we simplify. Okay, 5 and 6 are just regular old equations, just with distributive property here. Distribute. So I have 3a plus 13 equals 21 plus 3a. Remember, a negative times a negative is a positive. A negative times a negative is a positive. I'm cleaning up this right side. I get 3a plus 13 equals 18 plus 3a. I'll subtract 13 from both sides. I get 3a is equal to 5 plus 3a. I'll subtract 3a from both sides, and my variable actually drops out right here, and I'm left with 0 equals 5. No, it doesn't. 0 doesn't equal 5, so that is no solution. My variable disappears here. 3a minus 3a is 0. It drops off on both sides. This is not a solution of 0. A doesn't equal 0. A is gone. Okay, last one like this. We're going to distribute. Negative 3x plus 12, negative times a negative, equals negative 37 plus 4x. I'm going to add 3x to both sides, giving me 7x. Negative 37 plus 7x equals 12. Add 37 to both sides. I get 49 equals 7x. So x is 7. You can always check, plug it back in. Negative 3, 7 minus 4 is equal to negative 37 plus 4 times 7. This is negative 3 times 3, so that's negative 9. Negative 37 plus 28, also negative 9. It works. We check it. We plug it back in. Proportions, the easiest way to do this is to cross multiply. You can clear the fraction on number 7 if you'd like, but I am just going to cross multiply. So I'm taking the numerator of one side of the fraction times denominator of the other side of the fraction. So we are going to distribute 6 times x plus 8 equals. Then we will take the numerator of one side times the denominator of the other side. 9 times x plus 1. So this works because if I think of any fractions that are equivalent, yes, of course, there's a times 2 relationship here. That's one way to look at the relationship. But there's also a diagonal relationship. 3 times 8 is 24, and 6 times 4 is 24. We have this diagonal relationship that we see. And it sets up a nice equation for us of variables on both sides. So we have to distribute our 6, so that becomes 6x plus 48 is equal to 9x plus 9. I'm going to subtract the 6x from both sides, and I get 48 is equal to 3x plus 9. Subtract 9 from both sides. 3x is equal to 39, sorry. And divide both sides by 3, and I get 13. We could always plug it back in to check. 13 plus 8 over 9, and 13 plus 1 over 6. Is 14 over 6 equal to 21 over 9? Let's see. Let's look at that diagonal relationship. 21 times 6 is 126. And 9 times 14, it's 126. What do you know? I always can check that out. Make sure. Okay, 8. Same thing, cross multiply. So numerator times denominator of the other fraction equals numerator times denominator of the other fraction. So 7 times r plus 8 is equal to 12 times r plus 4. After I distribute, I get 7r plus 56 equals 12r plus 48. I'm going to subtract 7r from both sides. 56 equals 5r plus 48. Subtract 48. 5r is equal to 8. So r is 8/5. Okay, last two for this page. Same thing, cross multiply. Numerator times denominator equals numerator times denominator. So 11k plus 10. Is that what it says? Yeah. Okay, go ahead and distribute 11k plus 110 equals 72. I'm going to subtract 110 from both sides. Subtracting. Oh my gosh, I totally forgot about the bells ringing and now I got all nervous. I forgot about that negative out front. Let me start over again. So when you have a negative fraction, both the numerator and the denominator are not negative. Only one of them makes the fraction negative. So I'm just going to carry the negative with the 11 for this example. It could go with the 8. It really doesn't matter. So 9 times 8 is 72. And then I'm just going to distribute the negative 11 to both sides, or to the k and the 10. So that's negative 11k minus 110. Add 110 to both sides, and I get 182 is equal to negative 11k. Divide both sides by negative 11, and I get k equals 182 over 11, that fraction is negative. So it's going to end up being negative no matter what you do with the negative, but don't give it to the numerator and the denominator. It's just one of them. If they were both negative, they would cancel each other out and it would be a positive fraction. All right, last one. Cross multiply again. So numerator times denominator, go ahead and distribute. And then numerator times denominator is 12. So I'm going to distribute my 8. 8n plus 88 equals 12. I'm going to divide both, subtract. I'm going to subtract 88 from both sides. So 12 minus 88 is going to give me negative 76. Divide both sides by 8, and I'm going to simplify my fraction. Both 76 and 8 are both divisible by 4, so that's going to leave me with negative 19 over 2. Okay, watch the next video if you have questions on the back.